Math. Today we're going to look at three different forms of a vector. We're going to look at component form, linear combinations, and written with an angle measure. So, component form. To find the component form, and there's another video I have on this, but you're going to take the terminal point and you are going to subtract the initial point to write it in component form. So I'm given 2 points. My initial point of my vector is at 2, 3, and my terminal point is at 5, 6. So I'm going to take the terminal and I'm going to subtract the initial. So I'm going to take 5 minus 2, and that is 3. And I'm going to draw my vector to indicate component form. And then I'm going to take 6 minus 3 for my vertical distance, and I get positive 3. So the vector in component form looks like this. It's got these little symbols on either end, almost like parentheses, but they're kind of like absolute or inequalities, greater than or less than. It indicates a vector, meaning I'm going over 3 and up 3. And that is in component form, assuming that you're standard position where you're starting at the origin. Now, I can take that form and I can write it two different ways. First, as a linear combination. Now, a linear combination comes from the fact that you can have a unit vector in the horizontal direction, 1 unit is I, and in the vertical direction, 1 unit is j. So if I have 3 units to the right and 3 units up, I'm going to write that as 3 times I, 3 times j, and since it's a linear combination, I need to either add or subtract these. Since they're both positive, of course I'm going to add, so it's positive 3i and positive 3j. Had this been a negative, it would have been negative 3i plus 3j. Had this one been negative, it would have been positive 3i minus 3j. So you're just writing that as a sum or a difference. And the last one is when you take the magnitude and you multiply it times the sine and the cosine. Well, we need to know the magnitude of this vector. To find the magnitude, I just need to know its length. So let's draw it in standard form. So in standard form, I'm starting with my initial point at the origin, and I'm going over 3, and I'm going up 3. So my vector ends at the point 3, 3. Now, I know this is 3, and I know this is 3, so I need to know that length. So I'm going to use the old Pythagorean Theorem. So let's plug in 3 squared and 3 squared for a and b for the two sides. That's going to give me the length of my vector, which is also known as the magnitude. So 9 plus 9 is c squared. So 18 is c squared, which we take the square root of both sides, and that ends up being 3 square root 2. And we always take the positive because it's a length. So that is my magnitude. So I'm going to plug it in right here. And now I need to know my direction. Now to find the direction, I have to consider this angle theta right here. Now in order to find this angle, I need to use old school tangent, opposite over adjacent. So the tangent of theta is going to be 3 over 3, which is also known as 1. So to find the angle, I'm going to take the inverse tangent of 3 over 3, or I'm going to go ahead and reduce that to 1. So on my calculator, first make sure you're in degrees. I'm going to take the second tangent, which is inverse tangent of 1, and I get 45 degrees. So my angle is 45 degrees. Now let's put it in this form. I'm going to have my magnitude, which I just found to be 3 square root 2, and I'm going to multiply it by the vector cosine of 45. So I'm just plugging this angle in times the sine of 45. Now you may recognize that. That is a position on the unit circle, and instead of the hypotenuse being 1, The hypotenuse is 3. So it's the position. Once you evaluate it, it's going to end up being 3 root 2 times, well, the square, cosine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. And when you clean this up a little bit, this ends up being 3 times, well, root 2 times root 2 is 2 all over 2. So it ends up being 3. And you multiply the second one, you get the same thing. 3 times root 2 squared, root 2 over 2. They cancel, 3. And look, you have the component form of the vector. So there you go. And that's how you can write a vector in 3 different forms.